Good morning, dear students. My name is Ferhan Mazher, and today is 6th of February 2022. And right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O levels physics, and today we have set our hearts to solve a theory paper, and we have selected October-November 2021. 2-1 paper. This paper 2 belongs from the variant 1, or you can say it belongs from the zone 1. And this is the latest paper of the Cambridge O levels, which we have right now. And today we have set our hearts to solve its section A. In the section A, it consists of from question 1 to question number 7. The section B of this paper we will solve in another session, in another video, and soon I will upload that also. So let's start today's paper and let's see. Okay, so this is the paper, Cambridge Assessment International Education, Cambridge O levels, October-November 2021. Paper 2, the time allowed is 1 hour and 45 minutes. So let's go to the first question. He says the question number 1 is showing up on your screen. He says figure 1.1 shows a wooden bench of weight 2000 Newton. So here we have a wooden bench and its length is 2.2 meter. Its width is 0.48 meter. And these are the supports of the bench, and this point is Q, this point is P, and from the support, the left side of the support to the edge of this bench, this distance is 0.25 meter. He says each of the two supports has an area of 0.040 meter square in contact with the ground. Calculate the pressure on the ground due to the bench. Okay, so there are two supports. Each support is of 0.040 meter. So the total contact area will be 2 times 0.040 meter square. The weight of the bench is 2000 Newton. The pressure on the ground will be the weight of the bench divided by the total contact area with the ground. It's a 2 marks numerical. Let me show you. I have done this. Okay, so here we go. So the force is, the pressure will be equal to force divided by area. So that will be 2000 Newton divided by 2 times 0.04, which is the contact area. So when you enter these values in your calculator, you get 25,000 Newton per meter square. 25,000 Newton per meter square. Hopefully you understand. So let's go to the next part. So the next part is, he says the center of the mass of the bench is 1.1 meter from the left end of the bench and 0.24 meter from the front. So just one reason why the center of the mass is in this position. Okay. From here it is 0.11 meter, and from this edge it is 0.24 meter. So the center of mass is exactly in the center of this bench. The reason can be very simple, because its lengthwise it's uniform, and widthwise also it is uniform, and it is completely horizontal. So that's why its center of mass will be in the exact center of this wooden block or wooden bench. So let me show you my written answer. I have, okay, so here we go. Bench is symmetrical from left to right. Bench is symmetrical from front to back. Center of mass is in the middle of the table or in the middle of the bench. So this is my answer. Okay, so let's go to the next part. In the next part, they say, there is a force exerted vertically downward from the point P shown in the figure 1.1. Calculate the maximum force that can be exerted vertically downward at P without the bench rotating about the point Q shown in the figure 1.1. It's a 3 marks numerical. So let me show you that diagram. So what basically he's saying is they have applied a force here in the downward direction. So we have to find out the maximum force which can be applied here, and the bench will not tilt to this direction. It will not rotate about the Q in the anti-clockwise manner. The force here, the moment produced by the force here about this Q will be my pivot, and that 0.25 meter will be the moment arm for the force applied here. And the other force here is the weight of that bench, and it is acting here, and the weight of the bench is 2000 Newton, and it is acting at the center of the mass or center of the gravity, and its distance from the pivot will be 1.1 minus 0.25 meter. So because the Q is here, so this distance is 0.25. From here to the center of the mass, the distance is 1.1 meter. So from 1.1 meter, you subtract 0.25 meters, so you will have this distance from this point to the center of the mass. So that will be the moment arm of the weight. The weight is trying to produce a clockwise moment, and this force on the P, which is downward, is trying to produce an anti-clockwise moment. Until they are balanced, the table will not tilt towards the left side. So I can apply the principle of moments, and we can find out that value of the force which you will apply on the point P. So let me show you the numerical which I have done. Okay. So here is that point P. This is a simple diagram of that table. So this is the point Q where the pivot is, and its distance. The force F, the force P is applied here. The weight of the block is applied here. The table is acting here. So from pivot, the moment arm of the force at P is 0.25 meter, and the moment arm of the weight from the pivot will be 1.1 minus 0.25, and that will be 0.85. So according to the principle of the moments, the anti-clockwise moment is equal to the clockwise moment. So the anti-clockwise moment is the force at the P multiplies moment arm, which is 0.25, and the moment produced by the weight is clockwise. It will be 2000 Newton multiplies 0.85, and moment arm of the weight is 0.85 meter. So F, if I make F alone on one side, it will be 2000 multiplies 0.85 divided by 0.25. So F will be equals to 6800 Newton. So it's a 3 marks numerical. That was the question number 1, B, second part. Hopefully you understand. Okay, so let's go to the next, if there is a next part for question number 1. Okay, so the question number 1 is completed. Before going to the next question, let me show you the marking scheme. Okay, so on your screen, you can see the marking scheme of the question number 1 is showing up. I have already checked my answers. I've compared my answers with the marking scheme. One good thing you can do is you can pause this video and take your time and read this marking scheme carefully. And I always advise you that it is a very must. It's a must to check your answers with the marking scheme. You see, I am a teacher, and sometimes your teacher, I myself can make a mistake. So the best thing is, whether your teacher is providing you an answer, check the answer, compare the answer, your teacher's answer, the answers from the red spot, the answers from any book. Compare them with the marking scheme given by the Cambridge. Okay, so this is we are done with the question number 1. So let's move to the next question. Okay. So the next question coming up on your screen is figure 2.1. Shows a man mass 80 kg standing in a lift elevator. Okay, so he says the gravitational field strength G is 10 Newton per kg. Calculate the weight of the man. So we know the mass of the man, that's 80 kg. If you want to find out the weight, the formula for the weight is W is equals to mg. So very easily you can find the weight, W equals to mg. Just put those use that formula. Let me show you my answer. Okay, so M is 80 kg, the G is 10 Newton per kg, and weight is question. So W will be equals to mg. So it will be 80 into 10, and that will be 800 Newton. So the weight of the object will be, that man will be 800 Newton. Okay, so let's move to the next part. He says, this is the B part, and he says, the lift accelerates upwards uniformly at 0.50 meter per second square. Calculate the resultant force upward force on the man. We know the mass of the man, and we know the acceleration in the upward direction. According to the Newton's second law of motion, the resultant force which produces this, which can produce this acceleration, we can find by using the formula F is equals to ma. So F is equals to ma. Apply that formula. Very simple. The mass is, we already know, is 80 kg. So let me show you. So here we go. So F is equals to ma 80 multiplied 0.50. So the final answer will be 40 Newton. So the force required to produce, the resultant force required to produce an acceleration of 0.50 meter per second square in the man of 80 kg is 40 Newton. Okay, so let's go to the next part. He says the force exerted on the man by the floor of the lift. So the total upward force which is needed is the one force which is required to produce the acceleration, which we just calculated in the second part, plus we have to balance the weight of the man. So the force exerted on the man by the floor will be equals to the weight of the man plus the resultant force which is needed to produce the acceleration. So it's a 1 mark question. Let me show you my solution. Okay, so here we go. A force is equals to the weight of the man plus the force which was used to produce the acceleration. So it will be 800 plus 40, and that will be 840 Newton. So the total force which the floor of the lift will apply on the man is 840 Newton. Okay, so here we have the lift accelerates upward uniformly from rest for 4 seconds and then decelerates uniformly to rest in 4 seconds. The total distance traveled is 8 meters. On the figure 2.2, sketch the distance time graph. Sketch the distance time graph for this journey. Okay, so here we have a distance time graph, and we have to plot this distance time graph. The information which we have is that in the first 4 seconds, the body is accelerating, and in the last 4 seconds, the body is decelerating. And the total distance traveled is 8 meters. And because this is a distance time graph, the slope of the distance time graph shows the, shows the speed. And because first the body is accelerating, it means that the speed of the body is increasing. So the graph's gradient, the graph's slope should be increasing. And in the last 4 seconds, the body is slowing down, it's decelerating. So speed is decreasing. So the gradient or the slope of this graph should decrease. And then it stops. Okay. So in the first 4 seconds, I will draw a graph which will have an increasing gradient. And in the last 4 seconds, I will draw a graph which will have a decreasing gradient. So let me show you. It's a 3 marks question, okay? It's a 3 marks question. Let me show you. Okay, so here you can see that I have tried, because I have drawn this graph with the help of the mouse, and it's very difficult to draw the graph with the help of the mouse. But because you will have a hard copy of this paper and you will do this with your pencil. So this graph, and in the first 4 seconds, the graph is curving upward. Its gradient is increasing. We call it an increasing curve. And in the last 4 seconds, the graph is the curve. It's a curve and it's decreasing. Its gradient is decreasing. You see? And after the 8 seconds, it will become flat. So this is how you will draw this graph. So this we are done with the question number 2, I think. Yeah, question number 2 is done. So let's have a look at the. So let's have a look at the marking scheme of the question number 2. Okay, so the marking scheme for the question number 2 is showing up on your screen. What you can do, you can pause the video and take your time and read this marking scheme very carefully. I have already checked my answers with this marking scheme. So let's move to the next question. Okay, he says a type of nuclear reaction takes place at the center of the sun. The reaction releases thermal energy. State the name of the type of the nuclear reaction that takes place at the center of the sun. So you see, on the center of the sun, the nuclear fusion is taking place. In the nuclear fusion, you remember smaller nuclei come and they fuse into each other. They make a larger nuclei. On the sun, the hydrogen and hydrogen nuclei, they come close to each other, they fuse into each other, and they make the nucleus of helium, which is a larger nucleus. And in this process, a lot of energy is released. So here you only have to state the name of that reaction. The name of that reaction is a nuclear fusion. So let's move to the B part. He says the thermal energy is emitted, the thermal energy is emitted from the surface of the sun into space. The energy is transferred through the vacuum of space by thermal radiation. Describe the radiation that is emitted from the sun, from the surface of the sun. So from the surface of the sun is very hot, and like any other hot object, the sun gives out infrared radiation. Infrared radiation is a type of electromagnetic wave, and it do not require medium to travel. So from the sun, the energy, thermal energy coming to the earth is with the help of the infrared radiations. So let me show you, I have written this answer. Okay, so the nuclear fusion is taking place on the sun, and the B first part of the infrared radiation. It is one of the types of electromagnetic waves. Infrared is also given out from hot objects. So sun is also a hot object and it's giving out infrared radiation. Okay, so let's move to the next part, and it says, okay, the second part. He says, state the speed of the radiation in a vacuum. All the electromagnetic waves, this is the property of the electromagnetic waves, that all the electromagnetic waves, they travel with the same speed, the speed of the light in the vacuum, and that speed is 3 × 8 meters per second. And you are supposed to remember this number, 3 × 8 meters per second. Third part is the Earth is 1.5 × 11 meters from the surface of the sun. Calculate the time taken for this radiation to travel to Earth. So the distance is given 1.5 × 11 meters. We know the speed of that radiation, and the speed is 3 × 8 meters per second. And we want to calculate how much time that radiation will take to travel to Earth. So the formula of the speed is distance divided by time. And if you want to find out the time taken, the formula will be distance divided by speed. The formula will be distance divided by speed. Let me show you my solution. Okay, so here we go. So speed of the radiation is 3 × 8 meters per second. And the question number 3B's third part is, he says the time is equals to the distance divided by speed, and 1.5 × 11 divide 3 × 8. You will enter these values as I speak. Write in your calculator 1.5 × 11 divide 3 × 8 equals, and that will give you 500. So the time taken will be 500 seconds. So okay, so we are done with this numerical. He says Explain one advantage of wearing white clothes on sunny days. You know, the white color is a bad absorber of the infrared radiation. White color is because bad absorber of the infrared radiation. So what will happen on a sunny day, if you are wearing white clothes, the clothes will absorb a lesser amount of the thermal energy or lesser amount of the infrared radiation. So the person who is wearing those clothes will feel cooler. Okay, so let's go to my answer. So I have written this answer also. Okay, so the white color absorbs less amount of infrared radiation as compared to other colors. So on sunny day, wearer who is wearing those clothes stays cooler. So we are done with the question number 3, hopefully. Yeah, we are done with the question number 3. So let's have a look at the marking scheme. So here we have now showing up on your screen and the marking scheme for the question number 3. So pause the video and take your time and have a look at this marking scheme carefully. Read this marking scheme carefully. Check my answers, check your own answers, your teacher's answers, the answers given in the red spot, and compare those answers with the marking scheme. So, okay, so let's move to the next question. The next question coming up on your screen is question number 4. He says, in a coal-fired power station, coal is burnt and electric energy is produced. State the form of energy in the coal that is transferred to electric energy. You know, coal it has chemical potential energy. So because when you burn it, its bonds are broken and the energy is given out. So the energy in the coal is in the form of the chemical potential energy. Then he says, B, first part is state the principle of conservation of energy. So 2 marks numerical. You see the principle of conservation of energy, B, it says that in an isolated system, energy can neither be created, it can nor be destroyed. But the energy can be changed from one form to another form, and the total energy of that system remains constant. So let me show you my written answer. Okay, so here we go. So the question number 4 and its A part is, he says, the chemical potential energy. B, first part is, in an isolated system, energy can neither be created nor destroyed, but it can be converted from one form to another form of energy. Another sentence you can add here is that the total energy of the system remains constant. The quantity of electric energy produced by the power station is much less than the quantity of energy in the coal that is burned to generate electricity. Explain why this is so. You see, when the combustion of the coal takes place, not only the thermal energy is produced, and the thermal energy produced is transferred to the generator, some sound energy is also produced when the combustion takes place, and some light energy is also produced, and sound and light, they both go wasted. And the thermal, and especially the thermal energy which produced, is not all the thermal energy goes to the generator. Some of the thermal energy goes to the surrounding also. So the thermal energy which has gone to absorbed by the surrounding or by the air is a loss of energy. So that's why the efficiency of that coal power station is less. So let me show you my answer. Okay, let's have discuss on the state 1 environmental consequence of generating electricity in the coal-fired power station. In the coal-fired power station, you see the carbon dioxide is produced when the combustion of the coal takes place. That carbon dioxide has it's a greenhouse gas, and it produces the greenhouse effect, and that adds up in the global warming. So let's have a look at my answers. So thermal energy produced from the chemical potential energy, beside this, sound and light energy is also produced. Light and sound, they both are wasted. Thermal energy is also lost to the surrounding. Combustion of the coal produces carbon dioxide, which is a greenhouse gas, and it increases global warming. Okay. So we are done with the question number. We are done with the question number 4. So let's have a look at the marking scheme of the question number 4. Okay. So the marking scheme of the question number 4 is showing up on your screen. So you can pause the video and you can take your time and read this marking scheme very carefully. Okay, so let's move to the next question. The next question is question number 5. A plastic rod that is initially neutral is rubbed with a woolen cloth. After the rod has been rubbed, it is positively charged. Explain in terms of the particles why the rod is now positively charged. You see, when you rubbed that plastic rod with the woolen cloth, the electrons from the plastic rod have transferred to the woolen cloth. So that's why the rod has lost electrons and it has become positively charged. Then the question is, state what happens to the woolen cloth. The woolen cloth the electrons are transferred. Here you only have to state, but I'm also explaining to you, because the electrons have transferred to the woolen cloth. The woolen cloth will have excess of electrons, so the woolen cloth will become negatively charged. So let me show you my answer. So okay, rod when rubbed with the cloth has lost electrons. Electrons has transferred from the rod to the cloth. That's why the rod will become positively charged. Woolen cloth will gain electrons and it will become negatively charged. So here we have the next question. An uncharged conducting sphere is suspended from an insulating thread. The positively charged rod is placed near to the sphere as shown in the figure 5.1. So here you have a metallic sphere and here you have a positively charged rod. So what will happen? The electrons here, they will be disturbed. Electrons will accumulate on this left end of the sphere, and on the right end of the sphere, a deficiency of the electrons will be created. So here a negative charge will show up and here a positive charge will show up. The amount of negatives here and the amount of positives here will be equal to each other. So on the figure 5.1, draw the distribution of the charge on the sphere. So let me show you. This is so it's very important. This left side has become negative. This right side has become positive. The number of the negatives and number of the positives shown on this diagram, they should be equal to each other. Okay, so then the question is, explain why the sphere is pulled towards the rod. Why the sphere is pulled towards the rod? That's a 2 marks question. So try to understand from the diagram and then I will show you the. So you see this sphere is attracted to this rod. Why? Because this left end is negative. This negative and this positive have electrostatic attraction with each other. The right end of the sphere is positive and this rod is also positive. They both have repulsion with each other, electrostatic repulsion with each other. Because the distance of this left end and the rod is smaller, so here the force of attraction will be larger. And the distance between this positive, the right end, which is positive, and this positive rod is larger as compared to this distance. So here the force of repulsion will be less as compared to the force of attraction between this end and the rod. So because here the force of attraction as a whole will be more than the force of repulsion, so the metal sphere will be attracted to the positive rod. So let me show you my written answer. Left side of the sphere being negative is attracted to the positive rod. Right side of the sphere being positive is being repelled by the positive rod. Here, attraction is larger than repulsion due to less distance between negative side of sphere and the positive rod as compared to the other side. So hopefully you understand the whole of this explanation. Okay, so we are done with the question number 5, and now we are on the question number 6. But before going to question number 6, have a look at the marking scheme. So here you can see the marking scheme of the question number 5 is showing up. Pause this video and take your time, read this marking scheme very carefully. To check your answers, to compare your answers with the marking scheme is a very, very must. So hopefully you have understood this. You are done with the checking of my answers, especially with the marking scheme. Check your answers also with the marking scheme. So let's move to the next question. The next question is question number 6. Okay. So here we have the question number 6. He says a circuit contains a battery of electromotive force, EMF 4.5 volt, a 28 ohm resistor, and a variable resistor figure 6.1 is the circuit diagram. So here you have a 4.5 volts battery, and the EMF of the battery is 4.5 volt. Here you have a resistor who is 28 ohm. Here you have a variable resistor. So you can see here we have a battery which is 4.5 volt, and here we have a fixed resistor whose resistance is 28 ohm. Here we have a variable resistor, his resistance, we call it rheostat also. They both are connected in series with each other. The question is, the first question coming up on your screen is, he says that it's a 1-mark question. He says the battery consists of 3 identical cells in series. Determine the EMF of each cell. So if the cells are identical, so suppose in series the EMF is added up. So let me show you. I have done this. So because they are identical, so V plus V plus V is 4.5. So 3V is equal to 4.5. So V will be 4.5 divided by 3, and that will be 1.5 volt. Okay, so let's move to the next part. He says the potential difference across the variable resistor is 2.5 volt. State what is meant by the potential difference. You see, this is the definition of the potential difference. The potential difference is the electric energy converted into any other form of the energy when a unit charge flows through the resistor. So let me show you. Amount of electric energy converted into any other form of energy when unit charge flows through the resistor is known as the potential difference. The next question is, he says, calculate the resistance of the variable resistor. So we want to calculate what is the resistance of the variable resistor. So we are talking about this. I want to calculate what is its resistance. And I know the voltage drop here. So from the battery, the EMF is 4.5 volt. The voltage drop on the variable resistor, it is given in the question, is 2.5 volt. So out of 4.5 volt, if 2.5 volt is dropped here, so the voltage dropped here will be 4.5 minus 2.5, and that will be 2 volts. So here the voltage drop is 2.5 volt. Here the voltage drop will be 2. So if I know the resistance of this fixed resistor, 28 ohm, and I know the voltage drop here is 2, I can find out how much current is flowing through this resistor. Once I know the current flowing through this resistor, because they both are connected in series, so the same current will be flowing through this resistor. Once you know the current through this resistor and you know the voltage drop, which is 2.5 volt, you can find out the resistance of this variable resistor. R is equal to V by I. So that's the strategy how this numerical will be done. It's a 3 marks numerical, calculate the resistance of the variable resistor. So let me show you how I have done this. So here we go. So the voltage across the 28 ohm resistor will be equals to the EMF minus the 2.5, because the variable resistor was taking 2.5 volt. So the voltage for the 28 ohm resistor will be EMF minus 2.5 volt, and that will be 4.5 minus 2.5, and that will be 2 volts. So the current through the 28 ohm resistor will be I equals to V by R. The voltage drop on the 28 ohm resistor is 2 volt and the resistance is 28. So the current flowing through that resistor will be 0.0714 ampere. So the resistance of the variable resistor now, because both of them are connected in series, so whatever the current is flowing through the 28 ohm resistor, same current is flowing through the variable resistor. So the R is equals to V by I. Now I know the voltage drop across the variable resistor, and I also know the current flowing through the variable resistor. So now I can calculate how much is the resistance of the variable resistor. So that will be equals to 2.5 divided by 0.0714. That's the current. And the answer will be 35 ohm. So the resistance of the variable resistor is 35 ohm. So this is how you do this numerical. Hopefully you understand. So we are done with the question number, 6. So let's have a time. Let's take time, and here we go. So this is the marking scheme for the question number 6. Pause this video and take your time and read it carefully. To check the answers and compare your answers, your teacher's answers, your mentor's answers with the marking scheme issued by the Cambridge is very, very important. So let's move to the next question. So here we have question number 7. There are 2 parts of the question 7. Either you have to attempt this one or you have to attempt this question. The second question, which is in the option, that question is from the electronics. Okay. So normally our students do not prepare electronics, but in any way we will attempt both of them. So figure 7.1 shows a solenoid connected to an ammeter. The south pole of a permanent magnet moves into the left hand end of the solenoid. The ammeter reading shows that there is a small positive current in the circuit. Explain why there is a current in the circuit when the magnet moves. Okay, so you are bringing this magnet in, and this magnet is moving towards the right, and it's about to enter into the solenoid, and they say that the ammeter will show a reading. And so why this is happening? It's a 3 marks question, very famous question. You see, when this magnet is going towards the right side, so magnet has its magnetic flux. So when it's moving, its magnetic flux is passing through that solenoid, that coil. So when the magnet is moving towards the right, the magnetic flux is passing through that solenoid or that coil is changing. So when the magnetic flux passing through the solenoid or the coil changes, the EMF is induced in that, and so the current is induced, and that's why the ammeter shows a deflection. So this is a 3 marks question. Let me show you. And it's a very famous question. Okay, so here we go. He says the question, the magnet moves into the left hand end of the solenoid. Magnetic flux passing through the solenoid changes. Due to this, EMF is induced in the solenoid. Due to the EMF, current is also induced. That's why the ammeter showed a deflection. So hopefully you understand. Okay, so move to the next part. here we have. When the magnet is inside the solenoid, it stops moving. It is then pulled back out of the solenoid. Explain what happens to the ammeter reading as the magnet moves out of the left hand end of the solenoid. You see, when the magnet will stop moving, the ammeter will show zero deflection. It will show zero reading. And when the magnet will move to the left, the solenoid will show EMF induced, but the EMF induced will be in the opposite direction, and the deflection on the ammeter will also be in the opposite direction. So I hope you understand my explanation, but let me show you the written explanation as well. Okay, so this one is done. Okay, when the magnet stops moving, no EMF is induced, so the ammeter shows zero deflection. And this was not supposed to be written in the answer. The question was, when it will move to the left, what will happen? So when the magnet moves towards right, EMF induced is negative, and ammeter shows deflection opposite to the deflection when the magnet moves towards the right. So when the magnet moves towards the here I was supposed to write left. Let me correct it and then. So when the magnet starts moving, no EMF is induced. So ammeter shows zero deflection. When the magnet moves towards left, EMF induced is negative. Ammeter shows deflection opposite to the deflection when the magnet moved towards the right. So this is the answer. That's question number 7, and it's B part. Let me show you. I have increased the size. Okay. So this is the answer. Here I have changed this word. I by mistake I wrote here right. The magnet moved towards the left. So okay, hopefully you understand. And here we go. Okay, so then we have. So let's first check the answers, marking scheme, and that's the question number 7. Okay, so the first portion of the question number 7, which was A and B part. You can attempt these two, or you can attempt the next ones. So let's have a time, take time and check what's the marking scheme for the 7's first portion. So the marking scheme is showing up on your screen. You can pause the video, you can take time, you can read them, you can compare the answers. Okay, now let's move to the next part. Here we have figure 7.2 shows the symbols of a logic gate and its truth table. And it's a NOR gate. NOR gate is basically OR gate, and after the OR gate, we have put a NOT gate. So remember this thing, the OR gate is like addition. So for example, here you have two inputs. So the NOR and the OR gate basically add up both the inputs. And for example, and then you have put a NOT gate after that, and the purpose of the NOT gate is to invert the whatever is the input. So try to understand, you will add the inputs, whatever the answer comes, then you will invert it. Okay, so for example, if you have 0 0, the answer will be 0, and when you invert it, it will become 1. If the inputs are 0 and 1, you add them, you get 1, and when you invert it, you get 0. 1, and if the inputs are 1 and 0, these are the two inputs, 1 and 0, the OR gate will add them, 1 plus 0 will be 1, but the NOT gate will invert this. So the answer will be 0. 1 and 1, the OR gate will add these 1 and 1, the answer will be 1, but the NOT gate will invert it and the answer will be 0. So this is how the truth table is made. The NOR gate is A plus B. If A and B are the inputs, A plus B, and then you invert the answer. Okay. So this is Boolean algebra. Okay, he says state the name of the logic gate shown in the figure. This is the symbol for the NOR gate, N-O-R, NOR. It means OR gate, and after the OR gate, we have put a NOT gate. So we call it NOR gate. Okay, so that's the A part. Then it's a little difficult to answer. He says figure 7.3 shows two of these logic gates connected to make a bistable circuit. Terminal P and Q each have the logic level 0. So you see, try to understand this, and the the input to this up the logic gate number 1. This is NOR gate number 1. This is the NOR gate number 2. Okay, so the input to this NOR gate number 1 is P, and another input to it is coming from Y, and its output is X. This output X is fed to this NOR gate number 2, and its one input is Q, the other one is coming from the X. Terminal P and Q each have the logic level 0. The P and the Q, they both are 0. Terminal X has a logic level 1. This is 1. Explain why the terminal Y has a logic level 0. Try to understand this. This input is 0. He said Q is 0. The X is 1, and it is fed to as an input to this logic gate. So here we have 1, 0, 1, 0. So add these two. 1 plus 0 will be 1, and then invert it, you will get 0. So the Y will have the 0, 0 output. So let me show you my answer. I have written this answer. I will try to explain it to you. This is basic electronics. Okay. So the name of that gate is NOR gate, N-O-R. It means OR gate, and then we have a NOT gate. So we combine these two words and we say NOR gate. And remember, the NOR gate is Boolean algebra is A plus B. If A and B are the inputs, A plus B, and you invert the answer. So question number 7B, first part, P input is 0, Q input is 0. Output X of the first logic gate is 1. This is given in the question. It is input to the logic gate number 2. So 1 input to the NOR gate number 2 is 0, and the 1 input is 1. So its output Y will be 0, because you remember how we tell the output of the NOR gate. We add both the inputs and then we invert the answer. So hopefully you understand. Okay, so let's move to the next part, which is a little difficult. Terminal P is briefly connected to a supply of logic level 1. State the effect of this on the logic level of the terminal X and the logic level of the Y. So this was 0, it was 0, and here the output was 0. Here the output was 1. So now what you have done, you have changed the P from 0 to 1. So when you have changed it, okay, so when you have changed it to 1, so let's see what happens. So when this is connected to 1, so the input here will become 1, and this is also 1, 1 and 1. So 1 and 1, you add the 1 plus 1, it will be 0. And when you invert it, it will become 1. So the output here will become 1. So this 1 output will be given here. So it's 0 and it is 1. So 0 and 1, and see, it was 0, it was 1, and this was also 1. So 1 plus 1, it will be 1, and the output will be inverted. 1 plus 1 will be 1, and when you invert it, it becomes 0. So it will become 0. Sorry, the X will become 0. So when this 0 is fed here, the Q is 0, this is 0. So 0 plus 0 is 0. So this Y will become 1. So let me check my answer. State the effect of this on the logic level of terminal X and the logic level of the terminal Y. So let's have a look at. X changes to 0 and Y will change to 1. I hope you understand. It's a little confusing. Okay, so let's move to the next part. Then he says the terminal P returns to the logic level 0. Again, state the effect of this return of the value 0 on the logic level of the terminal X and onto the logic level of the terminal Y. Now, you see, P, you made it from 1, you made it again to the 0. So this was 1. So here we have 1 and 0. So 1 and 0, you add them, that gives you 1, 1 inverted, it will come 0. So this will become 0. So now this 0 is fed here, 0 and 0, 0 and 0, 0 and 0, 0 plus 0 is 0, 0 invert is 1. So this will change and this will remain unchanged. Oh my God. X, so that's the next part. Okay. So both X and Y stays at the new value. This is the answer which I wrote from the marking scheme. So Y was previously 1. So in the new answer, it will be still 1 and the X will be 0. So they both X and Y stays at the same, that stays at the new value. Okay. So now state how this circuit exhibits the property of the memory. This circuit is used in the computer to store the memory. Okay, so how does this exhibit the property of memory? That these outputs can tell you what was the state of the input at P and Q, the last state of the input at P or at Q. It's just an answer, okay? Just statement, remember that. The output shows which terminal P or Q last had the value 1. So it can show you which one has the value 1. The outputs can show you. So, my dear students, we are done today. So, my dear students, today we are done with this. Okay, so my dear students, today we have done October-November 2021 Physics 5054-21 paper. In this video, in this session, we have attempted the section A of this paper. The section A, B of this paper, I will do in the next video. I have tried my best to explain you the concepts. Last electronics question is little difficult, but whenever it comes with an option. You don't need to attempt it. And if you can understand it, then it's good. So thank you very much, everybody, for taking your time and reading this and watching this video completely. If you think that this video is helping you, if you think that this video has helped you to do this paper and has improved your concepts of the physics, please like this video and share the link of this video onto your Facebook accounts and onto your Instagram accounts and onto your Twitter accounts. And because this will help me promote my channel, and that is a fuel to my energy, and I keep on working. So thank you very much, everybody from all my students from India, from Sri Lanka, from Bangladesh, from Mauritius, from Brunei, from UAE, from Saudi Arabia, especially Pakistan. Everybody, thank you very much. Have a good day. God bless you all.